So this is the plastic that I got. As you can see, this is common household plastic, and I'm gonna destroy it. What I'm doing is cutting it up into little squares in order to fit this huge bottle in a 1 liter reactor. So here I have prepared everything, like the setup, the condenser, you can see it here, the flask, and the pump. Here we got the reactor vessel. As you can see, it's all made in of metal, and this is the plastic that I cut out. Our PPE, a lab stand, glassware to the top of the reactor, and that white strip there is called uh, Ceylon tape, which is a Teflon tape, and it can withstand around 300 degrees of temperature. And this is my notes to write my theory. So going on our paper, we can see the goal is to make an economically viable fuel from the pyrolysis of plastic. And for that we need data. We need the goal to have energy produced is greater or equal than energy consumed. Our objective here is to calculate energy and calculate energy produced. And there we have it. Okay, so here we can see the reaction taking place. It's already heat up. The joint is the pyrolysis is beginning to take place, and smoke from the reaction, which I assumed is gas and liquid, that is like broken down in response to the high temperatures at the reactor. Because what it does is that I heat up the plastic. There's a stove there, you can't see it. On full hot mode, it reached up to 600 degrees C of temperature, and that high amount of temperature causes the plastic, which is a polymer, to split up into smaller compounds. Because as you know, polymer is a long chain of hydrocarbons. By heating it up to such a high degree that the weak bonds on this chain is broken, and we now have a simpler, smaller compound of hydrocarbons. That the gas includes xylene, butadiene, methane, ethylene, propylene, and in liquids it contains oils and tar. We got our condenser 300 mil long, and that is the 75-degree condenser arm that is responsible for connecting the receiving flask to the condenser. Yeah, it's all coming together. Yeah, we're going there. So it's now time to disassemble everything that the reaction is finished, and I just need to keep everything. I just need to disassemble it as light as possible to avoid breaking the glass. Yeah, clean the glassware up, and so now this is the remains of the plastic. It was weighted at 114 grams, and it's like turned into carbon and nothing. It all turned into gas or solid. No, tar or or the fuel. And now here's our fuel. I'm just gonna filter it, but my dumbass thought that laboratory grade filter is would be used, but now I had to transfer it to another filter. That's like the coffee filter, which is much more larger compared to what I used. But that's alright. I still got the fuel like relatively pure using coffee filters. So it weighted about 55.24 um, grams of fuel that I collected. And life's good, bro. Life's good. I should know. The atmosphere is the trash bin. This is organic chemistry waste management.